Hi, my name is Neil Tandell, and this is my lab report for Physics 2212 Lab 1, charge tapes. The purpose of this lab is to understand how electrical interactions occur and look like through a piece of charge tape and another object. The materials for this lab include tape, a ruler, a flat surface, supporting objects, and glow script, which is a computational model which will be used later. The fundamental principles of this lab include Newton's second law, Coulomb's law, and gravitational force. These are some key figures calculations for this lab and will help with calculations later. The tape mass is 2 times 10 to the minus 4 kilograms, which is determined using the density and length of the piece of tape used in the experiment. The length and width of the tape were measured to be 0.2 and 0.02 meters respectively, and the resulting area of the tape was 0.004 meters squared. Given that the length of an atom is 1 times 10 to the minus 10 meters, the area of an atom is simply that squared, giving 1 times 10 to the minus 20 meters squared for the area of an atom. Lastly, the numbers of atoms was given by dividing the tape area by the area of an atom, which returned 4 times 10 to the 17 atoms. These are the videos from our experiment. In the first video, the charged tape was stuck to the end of the ruler, then it was attached to the hand moving towards it, as you can see right there. In the second video, a pencil was rubbed in the hair, which is known to give pencil a negative charge, and the tape attracted the pencil, which is how it was determined that the tape carried a positive charge. Lastly, two pieces of charged tape were held in close proximity to each other, and the repulsion of two like charged pieces can be seen in this video. Based on observational data, we made the following calculations. The gravitational force on Earth is the product of mass and the acceleration of gravity on Earth, which is 9.81 meters per second squared. Because the tape in the last experiment observed zero net force, the electric force must be equal in magnitude and opposite in direction to gravity, so it has the same magnitude. The charge was found using that fact, and Q was solved for in Coulomb's law equation. The number of electrons lost was found by dividing the charge of the tape by the charge of the electron, giving 1.31 times 10 to the 11 electrons lost. Lastly, the ratio of atoms per electron lost was given as shown here, and there were 3.05 times 10 to the 6 atoms per electron lost, which is where the tape got its positive charge. This is the computational model developed from the findings of the experiment. As can be seen here, the values calculated on the previous slide align with the computational model. So this model accurately predicts the motion of two charged tapes interacting with each other. The green arrow is the electric force experienced by the system, while the orange arrow represents the gravitational force experienced by the system. There were several assumptions and sources of error in this experiment. To begin, we assumed that air resistance and friction were negligible in the computational model. Also, we assumed that the charge on the tape was a point charge, and that the charge was evenly distributed across the tape. In reality, there is air resistance and friction to consider. The charges are unevenly distributed on the tape, and the surroundings, including handling the tape, cause the charge of the tape to change. So what if electrons had a positive charge and protons had a negative charge? In this experiment, and more generally, nothing would change, as like charges will still repel each other and the opposite charges will attract. By calling a proton a negative charge and an electron a positive charge, you're effectively only renaming charges and not the effect that they have. And lastly, why is it important to handle charged tapes as little as possible? As a charged tape interacts with its surroundings, including hands, it attempts to gain back the electrons it lost to reach electrical equilibrium, which reduces the effect of the experiment and creates more sources of error. Thank you very much for watching this lab report.